Okay, guys. Hey, listen. We almost there. Unit 12, all right. Part 6 of the final exam review. Let's go and knock it out. All right, guys. So Unit 12, man, starts right here at number 45. All right, so let's see what Unit 12 is talking about. This is given the parent function, f of x equals the square root of x. Write a transformation. Write a function that transforms f of x in the following ways. So this first one right here, guys, we have the function f of x. I'm going to call it g of x since we're transforming it, okay? All right, so for g of x, we have the parent function, the square root. All right, it says we're going to shift this thing right 3 units. So if I want to go right, I'm going to go x minus 3. And then I have a vertical compression by 1/2. Remember, vertical is outside, okay? And I don't need to do anything to it. If it says by 1/2, it is 1/2, okay? So this is part A. This is g of x. All right. For part B here, part B says, well, here I'm going to make this h of x, okay? So we're transforming this again. We have the square root. It says reflect over the y-axis, which means a negative goes right in front of the x, like that. All right, and then we have a vertical translation or vertical shift up 5. All right, so I'm going to go plus 5 right here. So h of x equals net square root of negative x plus 5. All right. All right. Number 46 here. Return my page. Work this thing out already. 46 right here says, given the parent function 2x squared minus 3, name the parent function of this transformation. So look, guys, if you strip away all of this, all right, strip away that, what's left? X squared. All right, so the parent function is x squared. That's the parent function, okay? All right, so I'm in it again. All right, another way to look at it is this. What's going on here? We have a vertical stretch. All right, a vertical stretch by 2, and you have a vertical translation down 3, right? So if you take those two things away, the only thing left is x squared. All right, so x squared, there you go. Guys, this is the parent function, okay? Parent function. Now, let's see here. For f of x equals x cubed minus 4, write a rule for each function. All right. Write the rule for each function. So this one, we're going to take f of x and subtract 3. So here's f of x, and we want to subtract 3 from it, right? Well, go ahead and simplify that, okay? So when we do that, you have negative 4 minus 3. You end up with g of x equal to x cubed minus 7. Like terms. All right, x cubed minus 7. For this next one here, man, for g of x over here, you're going to take the function f of x and you're going to subtract 3 directly from the x. See, as in parentheses with the x. Go over here, you're going to put in parentheses with the x. So you have x minus 3. See how that's x minus 3 looks the exact same now. Q, because of the q right there, minus 4. All right, right there. There's your final answer right there, guys. You could, well, no, we're gonna write right there, all right? Now, for number 48 here, 48 asks, now for this one, let x cubed minus 2x squared minus 5x plus 3, let f of x be that function. All right, write each function that performs each transformation. Write a function that performs each transformation. All right, we're going to reflect across the x-axis, meaning that I put the negative outside the whole entire function like this. Right? and then we distribute our negative. All right, and when you distribute your negative, you end up with negative x cubed plus 2x squared plus 5x minus 3. All right, so that right there in our red is your actual representation of flipping this across the x-axis, okay? Now, the next thing I want to do is, for this next part B, we need to reflect the function across the y-axis. All right, and when we reflect across the y-axis, what you got to do is you're going to put a negative right in front of every x value. So you have negative. Actually, let me do this with another color. Well, no, I'll keep the same color. I'm just going to remove this. All right. Now I'm going to do another color. I'll change my mind. All right. So you're going to put the negative right in front of the x. So you have negative x cubed, all right, minus 2 times negative x squared, okay, minus 5 times negative x, all right, plus 3, okay. So we're going to reflect this across the y-axis. Now you got to simplify it. Since this is a negative exponent, this stays negative. So negative x cubed. Right here, since this is a positive exponent, this negative x times negative x. Think about it. What's a negative times a negative? It's actually positive. So this becomes positive x squared. All right, so positive x squared times negative 2 is negative 2x squared. Right here, you have a negative x times a negative 5. Well, negative times negative is positive, so plus 5x. And then again, that's just 3. So plus 3. There's no x here that you had to reflect. So there we go, guys. There's our actual polynomial. Our function that reflects across the y-axis. Excuse me, it's getting late, y'all, man. It's like 10 o'clock. It's actually almost 11. Alright. So now, guys, we want to take this function, j of x, guys, which is 5 raised to the x minus 1. This is exponential, guys. Alright, and then find the asymptote and the y-intercept. Then we got to answer how is this graph transformed, alright, for the following graph. So check this out. Here's the function. Alright, I'm going to graph it, and it looks like so. Alright, notice it went down 1, and this is an asymptote, a horizontal asymptote. And there's our y-intercept right there. Alright, our y-intercept. So let me confirm that that's our y-intercept by looking at our graph, our table. Alright. Yep. That's our intercept right there. I don't know why I started there. Well, let me help myself out, man. Do an easier trick. I'm going to start my table here at, let's see. There we go. Let's start at 0. Now let's have a look. Alright, now what I just did was just start my table right here. Alright, and I'm looking for my y-intercept. Alright, that's our y-intercept, 0, negative 0.8. 0, negative 0.8, okay? So now let me go back to this right here. Okay. Our asymptote. Alright, we have a horizontal asymptote. Alright, at y equals negative 1. That came from this right here and went down 1. Alright, now we have to find our y-intercept. Y-intercept. Well, we saw that the y-intercept was 0, negative 0.8. Alright, that's our y-intercept. And then we need to describe the transformation. Here's the parent function, it's an exponential because the x is an exponent. Alright, well, we went right here. This says minus 1. So that x minus 1 means we went right 1, and then we went down 1. This negative 1 right here means down 1. All right, and just look at it real quick. Back to the graph. Sorry about that, guys. Get rid of that. Okay, here we go. So I just went down 1. It should be right there, but went down 1 and then it went right 1. All right. So now anyway, man, let's look at 51. 51 here says, given this function right here, negative, let me move that way, negative 1/2 of x divided by 2. All right, it says find the intercept and the asymptote and describe the transformation. All right, again, guys, right here I have negative 1/2, that's 0.5, that's 1/2, raised to the x divided by 2. All right, when I hit graph, guys, here's what I got. And there's my function. I have a horizontal, this gets closer and closer to 0, but never crosses it. Horizontal asymptote for y equals 0. That y-intercept, I'm going to look at my table. Second graph. My y-intercept is 0, negative 1. Alright, so let's look here. We have this negative says reflect the x-axis. Oh, sorry about that, guys. Got to charge that up. Alright, I need to charge myself up too. I'm going to go sleep after this problem. So when you see this video again, it'll be me somewhere else. Probably in my classroom. But anyway, we got to reflect the x-axis. Alright, reflect x. And then right here, we have a horizontal stretch. Alright, horizontal stretch by 2. Alright, by 2. Alright. Now, it's a horizontal stretch because of that right there. That 2, you have actually 1/2 x is multiplied directly to the x. So it's really, you do the reciprocal because it's in the parentheses with the x. Alright, so 2x. Yeah. So there we go right there. Now we need to describe the transformation. Oh, we did describe the transformation. The y-intercept. The y-intercept we saw was 0, negative 1. Let me check that. Yeah, 0, negative 1. And then the asymptote is y equals 0. So we have a horizontal asymptote. Alright. Man, guys, listen. That's number 51. Alright, pause this recording. I'll come back to it tomorrow. Hey, good night for now, man. Good morning, Josiah and I are back. We're back, baby. Oh, you don't want to be in the camera? Alright, fine. We're back.
I don't know why you're doing that.
Come here, man. Give me a hug. We're back, guys. So let's finish up this video. Alright. I love this guy. Get out of here. Alright. Let's see here. Number 52. Alright, in this problem right here, we need to write an equation for a function, alright, which is f of x of ln of x. Alright, translated 3 units left, horizontally compressed by a factor of 1/4, and translated 0.5 units down. Alright, so the first thing we need to address is the, let's see, it's a natural log, so I'm going to go g of x here is going to be, have ln. Now, let's see, 3 units left means I'm going to go x plus 3. Alright, and then horizontally compressed by a factor of 1/4 means I'm going to put 4 right here. Remember, you do the reciprocal. Alright, so 4x plus 3. Alright, left 3, horizontally compressed by 1/4. And then translated half or 0.5 units down, so minus 0.5. Alright, here's our equation right here, guys. Alright, so there we go right there. Number 53.
Y-E equation transforming to e to the x. Vet stretched by 3. Reflect y-axis and up 1. And it looks like this. Stretched by 3. Reflect y. See the negative. Up 1, so plus 1. That's how you do it.
Alright, you want to explain this one? Alright, I'll explain this one there, guys. It says, given this piecewise function right here, write a rule for each function. Alright, it says g of x, all right, a vertical stretch by 4. So guys, we're going to take both of these, okay, for g of x, and we're going to stretch them by 4, meaning I'm going to take x minus 5, and I'm going to stretch it by 4, which means you put a 4 out front, vertical stretch by 4. And this one, I'm going to stretch it by 4. So it goes outside, guys, okay? Notice that affects the y, so this stuff right here, these conditions won't change. Anyway, when you do that, guys, you actually get this right here. You get 4x minus 20, all right, because I distribute the 4, and here you get 12x. All right, and then it's still the same conditions because notice this is outside, so the x isn't affected. So it's x less than 2, and x is greater than or equal to 2. All right, so that is this piecewise function for A. Okay, now for B here, let's see here. We're gonna have a horizontal shift right by 2. So remember here, the x it becomes x right 2 becomes x minus 2. All right, so we're going to take this one and we go x minus 2 minus 5. All right, like that, because you got to go x minus 2. Okay, and this one you're going to go 3 x minus 2. Okay, yeah, all you do is make it look like this. Remember, this is right 2. Okay, now simplify that. And when we do that, all right, we're going to get, let's see here, x minus 2 minus 5. All right, see like terms right here, so you get x, x minus 2 right there minus 5. All right, or you don't know, let's simplify it. Let's simplify x minus 7 because I can actually combine those like terms. And here I get 3x minus 6. All right, distributed 3. All right, distributed 3. Now, understand that this condition is affected. See how this is in the parentheses is housed with the x. So that means these x's are affected. So I'm going to go x minus 2 and set it less than 2. Okay? And x minus 2 and set it greater than 2 or equal to 2. And then you just solve it. So you're going to add 2 on both sides to get x is less than 4. And add 2 on both sides to get x is greater than or equal to 4. So those are my conditions right there. All right, for this next one, guys, we got vertical translation up. All right, vertical translation up means I'm going to add 1 to this one. So you have x minus 5 plus 1. All right, so that gives you g of x equals x minus 4, because negative 5 plus 1 is negative 4. And right here you get 3x plus 1, because I'm moving up. So it's just 3x plus 1, guys. All right, 3x plus 1. Notice this is vertical. The y is affected, the x is not. So these do not change, okay? All right, so those stay the same. This is your g of x right here, all right? Now, finally, guys, 55 here, we got to find the x and y intercepts of f of x and g of x. Well, for f of x, what we're going to do here is find the x and y intercept. I mean, you can use your calculator for this, guys. All right, but to find the x-intercept, you will make y 0. All right, you will make y 0, so 0 equals x squared minus 25. You'll add 25 over to the other side, and then take the square root on both sides. So you'll end up with plus or minus 5. So the x-intercepts here are 0, are 5, 0. And negative 5, 0. All right, those are my x-intercepts. And now for g of x, I'm going to take f of x and multiply by 4. All right. Well, oh, and the y-intercept. I forgot to find the y-intercept for this one, guys. The y-intercept, if I make that 0, that's 0 squared minus 25, negative 25. So the y-intercept, guys, is going to be 0, negative 25. All right. X-intercept, y-intercept. You know you have 2 x-intercepts because x is squared. So 2 x-intercepts and 1 y-intercept. Now this is negative 4 outside of f of x. That affects the y, so it's negative 4 times this one. the x-intercepts don't change. Alright, so the x-intercept for g of x, alright, the x-intercept is still 5, 0 and negative 5, 0. Alright, the y-intercept though, however, is multiplied by negative 4. Alright, so if I take this y and multiply by negative 4, that's going to be 0 and 100. Okay, 25, negative 25 times negative 4 is 100. So there is your there's your y-intercept, guys. I'm just gonna show you, man. Check this out. If you were to take this f of x and multiply by 4, meaning if you put 4 out front, negative 4 out front, excuse me, and you want x squared minus 25, you'd end up with negative 4x squared plus 100. Alright, that would be your y-intercept right there. Because again, if you put 0 right here, alright, 0 times all of that is 0 plus 100 is 100. So that's your y-intercept. These won't change, guys. Okay, these won't change. Alright. Now let's jump over here to this one. Alright, for this one, to find the x-intercepts, guys, I'm just going to factor this, alright? And I get two numbers that multiply, give me negative 4, but also add, give me negative 1. It's going to be x minus 4 and x plus 1. Alright, now if I set that equal to 0, alright, I set both of those equal to 0. So my x-intercept, guys, is going to be 4 or 4 comma 0 and negative 1 comma 0. Alright, those are my x-intercepts. My y-intercept, guys, alright, if I made all the x's 0, my y-intercept would be 0, 4. Alright, actually 0, negative 4, sorry guys. Negative 4. Okay, that's my y-intercept. Because if you made that 0, that's 0 squared minus 0. It's 3 times 0, 0. 0 squared minus 0 minus 4 is negative 4. Now for g of x, see how this is negative 1/3 times x. So I'm going to take these and multiply by 1/3. Alright, when we do that, here's what happens. Now, for this side, guys, you see how these are the x-intercepts? Alright, well, understand this affects the x as negative 1/3 times x. That means it's actually going to stretch by 3, and I'm going to show you how. If I take negative 1/3 x and set it equal to my x-intercepts of 4, alright, and solve this, you see how I'm going to multiply by negative 3 on this side to cancel that out. So I multiply this by negative 3, my new x-intercept is 12. So that one's going to give me 12, 0. That's my first x-intercept. Take the negative 1/3 x again and set it equal to my other one, negative 1. Alright, I'm going to multiply by negative 3 on both sides. Again, the negatives cancel, the 3's cancel. I'm going to do it on this side as well. And that becomes 3. So my other x-intercept is 3, 0. Alright, you can use your calculator, guys, to very well check this. The y-intercept isn't affected. See how this affects the x? The y isn't affected, guys. So the y-intercept is still 0, negative 4. Alright. So now, guys, that concludes this whole entire video, man. This is unit 12. Alright. Hopefully this helps you with unit. Well, hopefully, if you struggle with this unit, you can replace it, alright?